an educative a day keeps unemployment away. Yeah, 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 yeah. That's what's up. That's what's up. All right. What are we doing today? Looks like I've been here before. We are fast and slow pointers. We're doing the middle of the linked list problem. Try to solve the middle of the linked list problem. Okay. Given the head of a singly linked list, return the middle node of the linked list. If the number of nodes in the linked list is even, there will be 2 middle nodes. So return the second one. Okay, and just put this in the code. Put this in the code. This is the code. Oh, there's your commit. Make this bigger so everyone can see on mobile devices. And let's use one view. So fast and slow pointers. What was it called again? Middle of the linked list. Oh, I didn't number it. 3. Shabam. Alright. Middle of the linked list. I keep going the wrong way. It's a sign that I should move this over here. Copy the statement as a comment. I'd rather I type faster on my I'm using an external keyboard. Okay. Also constraints the head is not null, so the linked list is not empty. So find the middle. The middle is 3 in this list. This one, the middle is 3 and 4. Return the second one, 4. The middle, okay, it's 2, so return the second one in the list of 2 items. So they're going to me through this, filling this as an input. 2, 4, 6, 8, 10. 1, 2, 3, 4, 5, 6 is the middle. Yep. 1, 3, 5, and 7. Let's give another input. 16. Okay, I think I understand it. Create 2 pointers, fast and slow. Initialized at the head of the linked list. Traverse the linked list following the slow barrel 1 step, 2 steps forward. When it reaches the last node or null, the slow pointer will point in the middle of the linked list. Return a node. This is already in the right. It's already in the right position. What are the odds? The code in linked list can be used to create a linked list out of a list. In traversal, traverse the linked list. Reversal, reverse the linked list. Okay, and get middle node. Interesting. Linked list node is the same. A linked list is a linked list. Okay, this is a simpler version of the linked list. It only has the insert method, create method, the display method. From what, 2 problems ago? Not from the happy number problem, it looks like. Reversal, it's how to reverse a linked list. How to traverse the linked list. Okay. Do I need all this stuff? I don't know. All right. Maybe. Okay. At this point, it's probably worth creating a folder with I'm already doing camel case, so I mean no camel. Is this camel case? No, not camel case. It's kebab case. I don't know, snake case, something case. So let me just do it so that I can link this node, put it here, export it. It's for this class of problems, and then link list. Put it in here, export it. Okay. And then, like I said earlier, this just has the insert, create, display. Insert, create, display. But this is more robust, I guess. So then I want the reversal. In this file can contain everything. Not default. I don't want this to be the default export. It's not any. It's a linked list node. Or no. This is traverse linked list. Same difference. Next is the default export. Okay, I think we're happy now. Linked list from. It doesn't need a folder actually. Let's move it over here. Need to trash. Hopefully this works and I don't have some weird issue. Nice. So I got that. It's the reverse. Get the middle of the node. The head is going to be a linked list node. It's not going to be null. It's because they said it's. Remember, they told us that head is not null, right? So that can't be null. So I have the head of the linked list, and I want to get the middle node of the list. I need to initialize 2 pointers. I can just use the cycle code to see how I did that. From the other time. Well, I mean, am I supposed to use the cycle code? Because in a stupid interview, they might not let me do that. Basically this. Actually, it's the exact same thing, believe it or not. Although I don't know, should I use this code, traverse? Traverse and link this. I don't feel like I need to use it, honestly. I don't need this, because head is never null. Slow is equal to head, fast is equal to head, fast and there's a fast, and there's a fast up next. I'm not detecting a cycle, because there should be no cycles in this list. So if slow is equal to fast, no. Actually, no. Should just return slow, actually. In my mind, that says it all. Yep. I have reason to believe that this is it. That is all this requires. Which would be amazing, but could be wrong though. That's an error, TypeScript. Yep, I did it again. TypeScript errors. That function, that feature doesn't exist in pure JavaScript. And voila, that's it. It worked. Yeah, that wasn't a hard problem. Didn't get my streak for today. Yay. Honestly, this streak thing is a bit annoying because, for example, right? It says 14 days, right? I missed this day, but they forgave me. And in hindsight, you should be able to skip 2 days in a week, like a weekend, and still keep your streak for something. I wish more streak things would do that for us, you know? I wish more of them would do that. But here we are. No, 14 minutes into the video. Might as well try another one. I don't think there's any need to visualize it. It's the same fast and slow pointer thing, so I can just, okay, I guess I can copy this. For instance, find the middle of this list, right? I have, let me borrow fast and slow. There's a left node, right node. let's see here. Let's make the blue the slow pointer. Use this fast pointer. And it will start at the middle. So what's happening in this algorithm, not you, sir, is that I move fast 2 steps, then I move slow 1 step, then I move fast 2 steps, and I move slow 1 step, then I move fast 2 steps till it reaches null, I think. Is that what's happening? Okay, they're doing it here. 2 steps, 2 steps, 2 steps. Now it's at the end of the list. This is a happy case of an odd number of goods. In the case of an even number of items like I have here, I can't move it twice because this points to null. Actually, I can, to be honest. I just set it to null, so it goes here, then it becomes null, so this stays here. But now the issue is in my code, if okay, so in this case, when it was here, fast existed, it wasn't null, and this wasn't null either, right, earlier when it was here. So those are some things to go to. Let me do it for an odd number of items. So let's say I got rid of 12, bring fast and slow. Put fast here, slow here. Give some room to see it in isolation. So I move fast twice, 2 steps, I move this 1 step. I move fast 2 steps, boom, I hit the end already. 1 step, hit 6, because there's no fast dot next, so this breaks out of the loop and then just returns slow. Just points at 6. Fairs. Fairly straightforward. I don't need, this is very more verbose. Oddly enough, I learned this trick to not like say, oh, not equal to null like that so explicitly. Just check for truthiness here, and yeah, that's it. I don't need to run through driver code, honestly. It's super straightforward. Oh man. Oh, 1. Okay, 18 minutes in. Circular array loop problem. An open array nums contains non-zero integers. Containing non-zero integers is given when the value in each index, where the value in each index represents the number of places to skip forward or backward. When skipping forward or backward, wrap around if you reach either end of the array. For this reason, we're calling it the circular array. Remember, if the circular array has a cycle, determine that the circular array has a cycle. A sequence of indices in a circular array characterized by the following: the same index is repeated when the sequence reverses in accordance with the formation rules. The length of the sequence is at least 2. The loop must be in a single direction, forward or backward. Assuming that the cycle in an array does not have to originate at the beginning, the cycle can begin from any point in the array. It's like finding a linked list cycle and a happy number all in one. How about that? It's less than 100,000. or no, 10,000. Each number inside is between negative 5,000 and 5,000. The number is not, no number is equal to 0. Okay, I need to look at these examples just to be safe, just to fully understand. Move one step forward to 3, then continue 3 steps forward to the last element. 1, 2, 3, yeah. Then finally return to the first element again. 1. So yes, this is a cycle. This looks like I have to convert the array to a linked list and then traverse based on the node values. And wrap around in the middle. A cycle will happen if somewhere in the list I wind up following the same path over and over and over and over and over again. Okay, it's fairly straightforward. 2, I hop 2 steps to -1, -1, I hop 1 step to 1, 1, I hop to -1, to 1, to -1, to 1, to -1, to 1, to -1, to 1. So starting with an element, a loop cannot be formed. For example, okay. Let's skip forward about wrap around if you reach either the array. Loop cannot be formed. Further, start with first element 2, move forward 2 steps. All elements follow the same pattern. Okay. The cycle cannot be formed. Let's start with 1, same thing. -2, 2, 2, same thing. 2, 2, 2, same thing. A loop cannot be formed, for example, because a loop cannot be formed, I'm returning false, it seems. And then this. Okay, start with any element. Any element. Wrap around if you reach either end of the array. Circular array. If the circular array has a cycle. Characterized by the following. Let me see that first example again. First element. Any element. Start with the second element. So I think I also have to iterate through, check all the different cases of the loop. And worst case, I'll go through everything. Looks like big O of m times n. I think starting with the second element 3. Move 3 steps, 1, 2, 3. Move 2 steps, 1, 2. Move 3 steps, 1, 2, 3. Move 2 steps, 1, 2. Okay, I think I kind of understand it. You have to loop through the whole array once. You don't here under any once you hit the cycle. And you have to start with any of the elements. Try it with any of the elements. So the interesting thing about this problem is if you hit 1 and okay, actually no, that's not the right thought. So 3, I think 3 steps, 1, 2, 3, 2 steps, -3, 3 steps, minus 3 steps. 1, 2, 3. Minus 3 steps. 1, 2, 3. 1, 2. 1, 2, 3. Yeah, actually, it's actually there. There's actually a loop. Say yes. I'm wrong. A loop cannot perform. For example, starting with the first element. Moving 3 steps forward to minus 2. Starting with the second element. Oh, 3 steps back to 2. Wait, did I miss something? 1, 2, 3. Minus 2. 1, 2, 3. I have not properly understood this problem. If 1 to the right is going to so 1, 4, 1, 2, 3, 4. 1, 4. In my mind, that's a loop already, but yes. Oh, it must be in a single direction, forward or backward. I see. The loop must be in a single direction. Okay. Must be in a single direction. So 1, up 3, then 1, 2, 3, and 1, up 3. Okay, it's in a single direction, so it's true. 2, minus 1, back to 1, change direction, false. 1 plus 1, change direction, false. Minus 1 plus 1, change direction, false. Minus 2 plus 1, change direction, false. This last condition, the loop must be in a single direction, forward or backward. So you'd have to actually step through everything at least once. 3, this is true because 1, 2, 3, minus 1, back, false. 3, 1, 2, 3, 2, 1, 2, 3, 1, 2, 3, 2. Okay, same direction, true. Okay, I think I get it now. So this is wrong. Let me look at this again. Reset the quiz. Try again. Can we look? So if I start at 3, I go 1, 2, 3, minus 2. That's wrong because I came back. Minus 3, I go 1, 2, 3, then 2. That's wrong. 2, 1, 2, 3, then 1, 2, 3, minus 2. No, that's wrong. So there's no loop. Yep. Then 1, 4, 1, 4, then 1, 2, 3, 4. Then 1, 1, 2, 3, 4. Yes, please. Okay. Minus 3, minus 2, then minus 3, minus 3, 1, minus 2. This is in the opposite direction, but it is a loop, all the same. Okay, boy, I needed those examples. Examples are everything, guys. They are super important. Examples are super important. Right? They are really important. Examples are really important. Really important. So 5, 1, 2, 3, 4, 5, minus 9, it came back, no, wrong. Minus 1 goes back to 5, and 5 jumps forward, that's wrong. 1 goes to 1, goes to minus 7, that's wrong. Minus 7 goes 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Then it goes forward, so that's wrong. Minus 9. This is important since they're all digits. I think they're all digits. Individual numbers. Oh no, they can reach 5 grand. Boys, the time complexity is a bit more, well, complex. Because like with this minus 7, I've gone through the list at least 7 times. And then if it's 5,000, if I can have a number up to 5,000, then I can go through this list like 5,000 times, unless there's a short circuit way to figure things out. Time complexity is weird on this. I like to see what it is. Let's try minus 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. It goes to 1, change direction. So no. And I had to go through the whole thing at least once. And then start hopping through the number of times it wanted me to. This is like an n squared thing, actually. Because you need to check. You're not allowed to not check. Right? Unless there's a trick to it. If we detect the loop, so 1, 2, then back, no, 1, 2, 3, 4, 5, then 1, 2, back, nope, 1, 2, 3, 4, then 1, then 4, nope, 1, 2, 3, 1, 2, 3, 4, backward, and minus 1, gives 3, nope, 4, 1, 2, 3, 4, then 1, 2, 3, then 1, 2, reach minus 4, and then go backwards. So nope, I had to do everything, and then the numbers affects it. There's no, the time complexity is not low. It's like n squared. Is it n squared? No, n times, or n to the power m? I don't even know. I want to figure it out. But first I have to play their games. Alright, looks like there's a 2-pointer way to solve this. Or fast and slow pointer way. Interesting. So Traverse states using fast and slow pointer starting from 0. 1 time, 2 times. Check whether be immediately the same node if yes, the red is detected. Return false if they do not encounter the transfer solution of the array. Oh, it looks like I only have to do this once. Boom. Shakalaka. This is interesting. And I need this recipe, actually. I need to know the recipe. I need to know the recipe. I need to know the recipe. Circular array loop. Circular array loop. And I need to follow the recipe. Wow, so the solution I was thinking of that makes this time complexity terrible is actually probably going to be the naive solution when we look at here. So JavaScript using fastest loop pointer starting from index 0. Okay. Let slow equals 0, fast equals 0. And then direction equals 1. Not true. Let me see. Let me see what they're trying to suggest to me. Okay. I just export. Did ChatGPT just solve the whole thing? In which case, I don't need anything. Let's find out. So it's a loop that's always on, and I get the next index. It takes in the array, takes in the direction, takes in the slow, and takes in the slow where the slow is pointed at. It takes in where the fast is pointed at. The fast is not -1. Okay. Set fast. If slow is -1 or fast, -1 or slow becomes fast. Break out of this while loop, that is. Now if slow is not equal to -1 and slow is equal to fast, return true. If it didn't change direction, I think. No, -1 is an index, actually. Otherwise return false. Okay. Interesting. Now what is good? And the next thing is direction is a number. I don't think direction should be a number. I think direction should be direction of index is either 1 or -1. So it's of type 1 or -1. It's not a number. Let me specify type called direction. Exactly. Type direction. Direction is 1 or -1. There's so much AI working with the code. Even Prettier is an AI application, technically. In my mind, right? Because I don't think it's by dealing with matrices before you can call it an AI app. Prettier is an AI operation. I think that formats my code automatically. All of computing is artificial intelligence because traditionally only human beings could do 1 + 1, you know? computers have been doing, that's like their first application, right? Computing, right? Compute 1 plus 1. So yeah, AI has been everywhere from the get-go. So let's say 1 is to the right, then -1 is to the left. Okay, then get next indexed, and the direction of the index. Does this help me? Does doing this help me by just using ChatGPT to print out the whole thing? That's how I code in real life, so it's like a bit weird if I can't do that. But many times it spews nonsense, so if this is complete rubbish, then I'll just have to redo it, the direction. So if the number at the index is greater than 0, that means I'm going to the right, otherwise I'm going to the left, whatever index I send. Okay, so if the direction of the index is not, the direction of the index is not equal to the direction I'm getting, my current direction, then return -1. Okay, that means so that I break out of the loop. So I can break out of the loop since I've changed directions. Yep, I think that's what that means. If they're not the same, otherwise if they're the same, the next index is equal to the index. Oh boy, this is confusing. And move it forward or backward. 1 time forward or backward. 2 times forward or backward. If the direction changes at any point, by taking a step, returns to the same direction. The same should continue to the next element. It does not change. Now fast and slow pointers check the quality of the list itself, not the individual items in the list. Oh, I think that was the difference between the two of them. Copy the problem statement. So I have the array, got the direction, I have the index. What am I doing? What am I doing? What am I doing? Next index. Okay, let's call it. Then I took in the current index, whether slow or fast. I added it to the index of the slow or fast. Index. I think this is for wraparound logic. Then, oh, I'm taking the number and adding it to the current index. Then, the modulo of that will give me the wraparound. That's for wraparound. Yes. Oh wow, it knew that. This is incredible. Wow. If the next index is less than 0. If it's less than 0, then add it to the length. Okay, so to give me the right place from the back. It's like, because if it's less than 0, let's say I was at -3, then you added 1 to minus, or because index can be negative. Get the next index. Change direction. Why is direction always 1 though? I don't think I agree with this. Direction is not always 1 in the beginning. It can be -1. Yeah, I don't think this is right, just based on my intuition. There's less than 0. And then make it a positive thing, because you can't have let's say I'm at index 2, and then the number is -5. I hit -5, then my index becomes -3. So I add it to the length of the array so that I have the positive equivalent of it, right? But if it is the same, oh, if my next index is my same index, return -1, so I break out of the loop. Okay, can be +1 or -1? Okay, it can be 1, because 1 doesn't mean forward. 1 can mean backward, right? It just means I'm calling it. Or can it? No, actually it means forward and backward because of this. Right? What would? Yeah, exactly. For forward. For the slow pointer, for the next index, for the fast pointer. And then I'm just getting the fast twice. This is when I get to do it twice. Yeah. One more time. If it hasn't changed direction. If it's changed direction, don't bother. And to do that, it will not bother by breaking here. And then trying again to break here. So I know that first pointer is not it. Interesting. If it was -1, this wouldn't do anything to just break out of it. But to break out of the loop though. But if it was a -1, and this didn't change direction, this didn't change direction, and this is not the case, then nothing will happen. It'll just reach here, loop again, and do it again. Get the next index, get it twice, and then check. This means we found the loop. Either we have a cycle or we don't. Is that true? Because this slow ever becomes -1, like as an index, it means I can return -1 here if the direction changed, right? Then return -1. In the current direction. Oh, this is where I check its current direction. I set it. I start off with everything as 1, but then each of the slow and the fast will have their own individual directions. The slow index, for example, if in the first case here, where I called it direction 1, it was less than 0, it would actually start with -1, and so I started by moving. I want to go forward, but that doesn't match where I want to go, so I'm just going to make it negative because it made me go backwards. And should this direction not be determined by, I have my doubts. I have my doubts about what this should be. I assume I want to start from left to right? So I said this, but then if I feel like I'm making leeway reasoning with this in my head, but the thing is, in reality, I might want to step through a debugger, right, to see what's actually happening, but it doesn't feel too complex that I can't think of it in my head at this point. So the index has its own direction, and I'm saying if that direction doesn't match my initial direction, which is 1, I don't think that should work. Then if I land on the same index, reach the same index. This is very complex. It's a very complex problem, and I suspect this might actually be the solution. It's the crazy part about everything. I have to strip the types though. Too many types. It's not gonna work. Or compile it to JavaScript. How do I do that? Can I compile this to JavaScript somewhere? I think so. Go to source definition. What does this do? Run code. Yeah, I think I might need to cd to what exactly? TS. Okay. TS node. Yeah, just save myself time for stripping out the JS. I think that will save me some time. Did it work? No, it didn't. Oh, it ran it. Oh, that's not what I want. I want a TypeScript compiler. TSC. Command not found. Yay. Just compile it to JavaScript for me, please. That's basically what I was asking. So I can take all this stuff and put it in here just to test, honestly. I need to not forget the export. There's an export so that their test can run it. Probably won't work. But this is, oh, it did. What are the odds? This case didn't work though. Well, since it worked, I would like to walk through the driver code because this is fairly complex. Still in TypeScript because why not? Oh, why is it weeping? Why are you weeping? Oh, of course, because of this thing. Just delete this. Yeah. Run it once. In this case, test case. Oh, then it should be true, right? It's a true test case. How can I tell? And also this one should be false. Oh, I gave false, but it's wanted true. This one is very complex. This one's supposed to be false. Oh no, this one's supposed to be true. It got false, actually. Right now. I'll just use this because why not? Now I need to put a bunch of breakpoints, especially in here, on here, this if statement. This if statement as well, just so I have a deeper insight into what exactly is happening here, because this is a lot more complex. Turn on my debugger. Yes, no, show me what's up, show me love. I have to watch a bunch of stuff. The slow pointer is worth watching. The fast pointer is worth watching. The numbers don't change. The direction is worth watching. Is it the direction worth watching? Direction doesn't change. I never set a direction at any point in time. So, in fact, I probably don't even need to describe it here. But on the closure, go next. Okay. Cancel. Cancel. I need to. Ooh. So now it's getting the next. Okay, I'm in here, so these values aren't there anymore. I wish I could keep. I wish I didn't like throw away, seemingly throw away. I wish this wasn't a thing, but it tends to be, unfortunately. But I know slow and fast are 0 though, so I'm in this thing where the direction is 1, the index is, wait, what? What's the index? Okay, the index is 0. And I think I can look it up here, right? 0, yep. I can't see slow in this context. I'm outside this stack. I wish it would preserve it though, and I could walk, I could jump into it, maybe in the closure, but no. It's like, no sir, I'm not gonna do it for you. I wish you would, sire. You know, but no. Could it be in the global context? No, it's not. If I wanted to keep it, I could pollute it. This is, so I'm dealing with this case right here. I pass in the array, pass in the direction 1, passed in, which is presumptuous in my opinion, because in this case the direction is 3. So, but what if this started out negative? Then what would I do? You know, what if this 3 was minus? It would return -1 almost immediately. Now is -1 a bad thing? Possibly, because if this was negative, like in the case of, okay, they don't give me any example where the input starts out negative, so it might look as if that is a good idea, but in my opinion it is not. That is not a good idea. You should get the direction from the value. The initial direction should not be 1. The initial direction, in my opinion, should be the value. Exactly. Of the slow. Right? In my opinion, this is more accurate. If that is bigger than 0, then make it 1, because the direction is on the right. Otherwise, make it left. In my opinion, it shouldn't be. Can I start again? Yay. Okay. So direction I know is 1. Index is 0. Direction is 1. So they're in the same direction, right? This is 1. They're equal, so this won't happen. Don't break out. The next index is the current index, 0 plus 3. That gives me 3 for the next index. It's going to be 3. If it's less than 0, which is not, it doesn't wrap around. Otherwise, if 3 is equal to 0, which is not, return the next index to slow. So slow is going to be 3. Fast is going to be first be 3, and then because it starts off at the same place, and then it's not -1, right? Because if it's -1, it would have been -1 if I changed direction. I didn't, so it's escaped that wrath. Or it would have been -1 that is a sentinel, like to break out of a loop. If I wound up in one hop right back where I started, so that's -1 immediately, and it would break out of this whole loop right here, and then and that's a technique to note, using its value, setting a value that should not be, so that I can break out of the loop whenever I need to. If slow, if it's not -1, and if it somehow equals fast, because the thing is loop, it went ahead of it, yet it wound up at the same place, and that's a cycle. It's a cyclic loop, then yeah, for sure. Otherwise, if it didn't, return false, because it means there's no loop. Do it again. So I'm setting fast twice. The direction of the index. So in this case, the index is 3, the direction still 1. So it's gonna skip that. Oh, interesting. It didn't. Wait, what? Did it? Oh, fast became -1. It's saying, oh, because at 3, then move on. Is it good? 1, 2, 3. Oh, it's -1. Yeah, it's -1. So it changed direction. So yeah, it's -1. It's -1 now. So get out of dodge. Change direction. So fast is -1. This is not though, but it is. So it's gonna break out of the while loop and come out here. Now if slow, 3, that is true. But however, 3 is not equal to -1. So it's not true. Okay, like I said, this is supposed to return true, but it's saying false right now. And that is because it broke out prematurely. It didn't loop through the entire array. It's supposed to loop through the entire array. It's not supposed to give up. It's not supposed to give up. It's supposed to move on and try it from 3. Set slow and fast to 3, and then try again. Set slow and fast to 1. And until it passes through the whole loop, it's not supposed to give up. So to terminate a for loop, I need a for loop. Let's see if Copilot can pull it out for me. Aha. I think this can fit in the has cycle. Yep, exactly. Exactly, same stuff. Mm-hmm. Get rid of all this. In fact, I should just, instead of saying if this blah 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 blah, I should just return. think so. I think this is it. Oh wait, ooh, actually, no, because this breaks at the end of every loop. It's gonna break out of the for loop every time. The other way is better. And then if that never happens, return false. Yep. I think this is it. This should do it now. Let me debug this real quick. I want to disable all the breakpoints. Can I do that? How do I do that? Where are my breakpoints? Oh, there you are. Add functional breakpoints, toggle back to breakpoints, turn them all off. Just press play. True. It's supposed to return true, but it's returning false right now. So this should work now. So I'm gonna turn this into JavaScript, the TSC, the TypeScript compiler. This is fixed, so I don't need. Okay, and don't forget my export. I can call it a day. This is how we code these days. You're debugging GPT's output because so much of it already exists. But I still gain by doing this because now this pattern is in my head, right? It's part of my toolkit if I were to see it out in the wild. What I'm more interested in right now is the time complexity, because I had a naive approach in my head which was exponential almost in time complexity, but because you have to loop through it and then based on the number of things there. But this, I think, halves that problem space. Because let's say you hit 5,000, even with the fast pointer, and the number at some point, like one of these was like 5,000. Yeah, you would still have to go through this 5,000 times. Would you know, actually, the modulo doesn't do that. That's not how modulo operates. Modulo is an efficiency. It's just going to divide it. So I don't have to literally walk through everything. I just need to know the length of the array ahead of time and do the division. So I only walk through it the array amount of times, because that's the max value, right? Where the modulo becomes 0. It can only go from 0 to 1 short of the length. In which case, even my naive approach, single pointer approach, would be bad for space, because I'd have to be keeping track of everything. Just like the first, the description of the naive solution to the happy number, I think. Similar to the naive solution, I think was what I had in mind here. In a hash set, yeah, I'd have to keep a hash set. That's what was in my head at first. But I'm looking for a cycle, so no. Whenever you're looking for a cycle, reach for a 2-pointer solution. A fast and slow pointer solution. It's a variation of the 2-pointer solution. Okay, did I get this? Yay, it works. I would have had to keep a hash set. Oh, the fast and slow pointer. Super interesting. Super interesting. This is the hardest one so far. Traverse the array. Keep track of the visited elements, N squared, exactly. Okay. Exactly. Check what it is first. The direction. Okay, theirs is more, it's less elegant, I would say. But I think similar type of complexity. Naming this is not that. It's like a double negation. Is not cycle makes me have to like use this like negation again for it to return true or false, which is fine, I guess. And I just said has cycle instead. Did it in fewer lines of code, I think. 18 to 60. They did it theirs in fewer lines of code. No, 18 to 60 is like 40 lines of code, 42 here, and 61, yeah, 43 lines of code. They're doing theirs in 51 lines of code. This is very complex. Okay, the time complexity is still n squared. So it's not a simple array. It's not a simple solution. It grows exponentially as the input size grows. Because you always have to loop through the array once. And for each one, you might end up having to jump quite a few times before you figure out it's not an array. But the space complexity is 1 though. So it is like a memory optimization, pretty much. Because there's always n squared. There's no way to stop it from being n squared. Alright, I think that's enough. 1 hour, 20 minutes. It's 10 o'clock. Yep, time now.